All right, welcome everybody to ACT Math Review with Mr. Tui. We've got a student with us, Abby. Say hello to everybody, Abby.
Hello.
Thank you, Abby. Appreciate it. And we're just going to kind of pick up with that ACT Math practice test that we left off with in our last session. We're going to keep kind of chewing through these questions and seeing, studying some of the concepts that are tested on, some of the strategies you can use that really simplify this test and simplify these questions. So let's just jump right into the questions. Abby, go ahead and read question number 11 for us, please.
Question number 11 is students studying motion observed a cart rolling at a constant rate along a straight line. The table below gives the distance d feet the cart was from a reference point at 1 second intervals from t equals 0 seconds to t equals 5 seconds.
Okay.
Which of the following... Oh, sorry.
Yeah, go and keep reading. Keep reading. A lot of stuff there, right? But
Lots. Yeah. Which of the following equations represents this relationship between d and t?
What are we solving for here first? Let's start with that, Abby. What are we solving for?
What represents the relationship between d and t?
Yeah, what's the relationship between d and t? D is the feet, I guess, the distance in feet of a cart from a reference point, and then t is time in 1 second interval, time in seconds.
Time. Okay, gotcha.
Yeah. So that's it. I mean, and basically we're just, the question is saying, what's the equation? What's the equation? You know, and that's, you know, that wording here, what's the relation between d and t? All an equation does is represents the relation between variables or values. So, and if you look at the answer choices, you know, you can kind of see like there's, 4 or 5 equations here. So one of those is the right equation that describes the relation between the distance and time between d and t. Does that question make some sense?
I think so.
Okay, good. Yeah, I mean, what's the equation? Now, here's the deal. They give us this nice little chart right here, right? Of time values and distance values. Okay? And, it would be really tough to go straight from that chart to developing the equation. There is a way to do it. But I think a much better approach to this question, or a question like this, is just to test the answer choices. For example, we know when the time is 0, when t equals 0, the distance from this reference point is 14 feet. Does that make sense?
Yes.
Yeah,
so
those are like ordered pairs there. Yeah.
Okay.
What were you saying?
I was going to say 14 should be in the equation. So.
Well, I don't know. I mean, maybe not. I think I think it's going to end up in the equation. It will.
Okay.
But like, look at this set of values right here. We also know when t is 1, right? When the time is 1 second, the distance from the reference point is 20. So when t is 1, d is 20. I don't know whether we're going to see a 1 or a 20 in there. I don't know. So I wouldn't think so much in those terms. That does work with 0 and 14. But just we know, at the very least, that when t is 1, d is 20. Does that make sense?
Yes.
And we also know that when t is 2, d is 26. So we can really just test these values, plug those into the answer choices, and see which answer choice gives us a true statement for all those values. Does that approach make sense?
I think so.
Okay, well, let's do it. Let's do it. I want to see you plug in these values into the answer choices. We'll start with answer choice A, and we'll start with this set of values here. When t is 0, d is 14. So plug that into answer choice A and make d 14 and make t 0. Let's see if we get a true statement. Looking good, looking good.
Oh, that was awful. Sorry.
No, you're good. Your handwriting is better than mine. Good heavens.
Is that right?
Yeah, it's perfect. Is that a true statement,
yes,
by the way?
Okay.
Is that a true statement?
What's the true statement?
Well, like this equation right here that you wrote out.
Yeah, I mean...
Is that true?
I think so, yeah.
Yeah, I'm pretty sure 14 equals 14.
Yep.
Right? Yeah, so keep answer choice A. We can't get rid of it. Okay? Let's plug into the other answer choices right now. I'll clear some space for you. Plug into B.
Okay, let's see. D, so 14. Gotta think about this. Hold on. 6.
If you just want to write 6 times
6 times 0,
that's fine.
Oh, 1?
Oh, I'm sorry. No, we're plugging in 0. You're right. I was moving on to the next
so like
one.
that.
Yep, you were right.
Okay.
Yeah. You could also do parentheses too.
Okay.
That might be more clear, especially sometimes your multiplication sign looks like an X or Y, but it's the same thing. Is that a true statement?
Yes.
I don't think so.
Wait. Let's see. 6 times, okay, which would be, no, it's not.
What's 6 times 0?
0.
0. So that's going to be 0 plus 8. We see that, right?
Mm-hmm.
Equals
which
14.
Is not 14.
Which is not, definitely not equal to that. Does that make sense?
Yes, sir.
Okay, good.
Yep.
All right, so this is a great time to address PEMDAS, and I think we talked about it in the last session together, and I was like, oh, I'm going to add that to the cheat sheet because it wasn't on there, and I just did moments ago. And so let's go to the cheat sheet real quick, and this is at the very bottom of the cheat sheet, or toward the bottom, just above the glossary. We've got a little part on PEMDAS, okay? So PEMDAS is an acronym for parentheses, exponents, multiplication, division, addition, and subtraction. Sort of the order that you need to simplify things in first. I want to talk about it real quick, and we'll apply it here. First thing is calculate its parentheses, right? So you calculate what's inside the parentheses first. That's where you should start, okay? So if there's any addition or subtraction or multiplication or division or anything, whatever, inside the parentheses, do the parentheses first. Simplify that. Then take care of the exponents. That's the second part of PEMDAS. Apply the exponents. Then you can do multiplication and division if you need to. And then lastly, do addition and subtraction. Most students have learned PEMDAS before at some point, but it can be a little tricky to apply. But I think we can see it applies here in this question very, very nicely, right? Because before we do our addition and subtraction, we need to do our multiplication. So it's 6 times 0 here first, which gives us 0, right, as we established. 0 plus 8 is 8. 14 does not equal 8, so we know it's not answer choice B. Any questions about that, Abby?
No, sir.
Okay, we might come back to PEMDAS again a little bit if we see we need to use that to simplify some expressions. So let's plug into answer choice C. I'll clear some space here. Plug into C, and let's see what happens.
All right. Do you want me to do like color in the thing?
I don't really care. Yeah, I don't care about colors. Yeah.
All right. Yeah, so C, we got 14 equals 6.
Let's practice. Okay, so let's use the parentheses. Yeah, I would use parentheses sort of signify multiplication. Exactly right. You don't want to use that multiplication sign, I think, in operations, especially if you're dealing with like x's and y's. It's just going to get really, really complicated. So I love using parentheses.
So we're doing 14, right?
Yeah, we're doing 0 and 14.
0 and 14.
So T is 0. Mm-hmm.
So it's 0 again. Is that right?
Yeah.
Okay. Hold on. Let me redo that.
You got it. I understand it's parentheses. You're good. You're good.
Okay. And then plus, what was it, 14?
Yeah. Whoa. Is that going to give us a true statement?
Yes, it will.
Let's do that PEMDAS thing, right? We got to multiply again.
6 times 0?
0, right? Oh, yeah, and that's 0, right? Plus 14. Yes, you're absolutely right. That
plus 14. Oh, okay.
Yep, you're right. Absolutely right. All right, so we're going to keep answer choice C. Good.
Okay.
Go ahead and do answer choice D. I'll clear some space again. Sorry, I was looking at it the wrong way.
No, you're good.
Go ahead and plug into D.
Yep. Okay, let's see. Oh, gosh, my OCD is like, get this straight.
Let me remind you how bad as long as we can read it, we're good. Yeah.
Okay. 0 plus.
All right, is that going to give us a true statement?
Let's see. No, it will not.
No, it will not. So D is gone. What about answer choice E?
Okay, let's see.
That's not looking great.
Nope.
Okay, that's definitely not right. No, definitely. 14 is not equal to 0. All right, so it's either A or C, right? Because those are the only two answer choices that give us a true statement for the values when T is 0, D is 14. Does that make sense, Abby?
Yes, sir.
Okay, excellent. So what do we do now? We got to just stop and guess between A and C? What do you think we should do?
I mean, we could, but that's probably not the best way to do that.
we could. That is a possibility. It's true, right? No, but then we don't have to guess. We can just test another set of values.
Oh, okay.
Right? Let's try the 1 and the 20, right? I mean, I think it makes sense to start with the smaller values, right? We could do 5 and 44. We could, but let's just do 1 and 20. Plug those in. So T is 1, D is 20. Let's see if we get a true statement. And we only have to plug into A and C here, right? Because the right answer has to be true for all the values.
Okay. So T is 1. So that is not
a true statement. So I sure hope C works. Let's see if we can confirm it. Plug into answer choice C. Hold on. What are we plugging in for the D value?
Oh, not that.
Not 14, right? Yeah.
Okay, hold on. Let me fix that. Okay. Sorry, gotta focus this a little bit better. Okay, 20 equals... Is that, yeah, 1 plus... So that is a true statement.
That is a true statement. Yeah, 20 does equal 20. Last I checked, so we can confirm it is indeed answer choice C. Any questions about that?
Cool. Nope.
I love testing answer choices. I think it's one of the best strategies and general approaches to the questions you can have. It's just not easy to go straight from this to developing the equation. There is a way to do it. There is a way to do it. But just test the answer choice, it just turns everything into middle school arithmetic. So
yeah, the best for sure.
Okay.
And you can be confident in your answer.
I think so too. Yeah, right. Because we got rid of all the bad ones and we confirmed the right one. You definitely know it's. I don't have the answer key in front of me. I don't need it. I know it's C. Does that make sense?
Yes, sir.
Awesome. All right. So let's keep rolling. See, that was number 11. Let's do. Oh, a little geometry here.
Uh-oh.
A little geometry. That's all right. That's all right. All right, go and read number 12 for us, please, when you see it on the screen.
Okay. The length of a rectangle with area of 54 square centimeters is 9 centimeters. What is the perimeter of the rectangle in centimeters?
Oh, my. What are we solving for here, Abby?
The perimeter of the rectangle in centimeters.
Yeah, let's talk about some of these terms here. First of all, do you know what perimeter means?
Perimeter, the outside, correct?
Yeah, kind of you add up all the lengths on the outside. Yeah, yes, that's the perimeter. It's all the way around. Okay. I want to try drawing this rectangle. Do you think we can just try to draw this rectangle? I mean, it's got to have an area of 54 square centimeters. Okay, we'll figure that out. And the length of this rectangle is 9 centimeters.
Okay.
All right, so just draw me a rectangle, make the length 9 centimeters. We'll start there.
Okay, let's see. That's probably good, right?
Yeah, I mean, if we need to adjust it, we'll adjust it, but just show me a rectangle. Yeah, great. Okay.
Okay.
Let's make the length 9 centimeters.
Okay, so just write down 9. Oh, the length.
Yeah. I always get length and width kind of mixed up, but I don't really care. I'm not too worried which one you pick.
Right here, right?
Yeah, that'll work. Some students might describe that as the width.
Length.
You know what I'm saying?
Yeah.
But I don't think it matters too much.
Okay. Yeah. So that's 9.
Do you mind if I'm going to label the other one 9?
Yeah, for sure.
Yeah. So that's 9.
Yeah, okay.
Okay, but we know the area is 54, right? They tell us that in the question. Well, do you know how to find the area of a rectangle? Have you studied that before?
I have. I literally could not give you a good definition.
Yeah, that's okay. Let's go. I think I've got it on the cheat sheet. Let me check.
Okay, that's where I was going.
Yeah, it's on the cheat sheet. So you've got some geometry here somewhere. There we go. Okay, great. Yeah, so basic concept G. That worked out nicely.
Yep.
And area of a rectangle right there. It's the third bullet point. Go ahead and read that for us, please.
Area of rectangle equals length times width.
Length times width. That's it, right? Same as area of a square, right? I mean, it's just you multiply two sides.
Exactly.
That's it, right? It's length times width. That's pretty straightforward. So we know that when we multiply the length 9 times the width, we get 54. Well, you should be able to tell me what the width is then.
Yep.
What's the width going to be?
It would be 6.
Yeah, I think it's going to be 6. Absolutely. So I'm going to label that. That's 6.
So is that the answer?
Well, they're not asking for the width, are they? What are they asking us for? What are they asking us for?
They're asking for the perimeter.
They're asking for the perimeter, but we can figure out the perimeter because I think we know what this side is right here, and we know what this side is right here.
Okay, so sorry.
You label it. You label it.
Okay.
We know the other sides.
Okay. All right.
Yeah. Absolutely. What's the perimeter?
Is it just added all all the numbers added?
Add up all the sides. Add up all the
18, 12, so 30?
30. There's your answer.
All right. Oh, wait, that's the answer? Okay, cool.
I mean, right? That's the perimeter, isn't it?
Yeah, that makes sense.
Yeah. And it's so funny because this question, you see it for the first time, it's like, oh my I don't know how to do that. Right? I mean, it sounds kind of complicated. I think it's tough to go right from the words and the values in the question to finding the answer. I think that's tough. But once you start drawing it and thinking in concrete terms, once you see it, right? And again, you got to know that formula, right? Length times width is the area.
Yep.
But as long as you know that, you can just be like, oh, that means the width is 6. Oh, okay, so the top one is also 6, and the side on the right is 9. Oh,
Yeah.
30. That's it? Was it that easy? Right? Like, that's kind of the reaction once you see it. And it is. I really recommend, if you can draw a picture, especially on a geometry question, always draw a picture.
Okay.
There's so much you can figure out just sort of visually. You know.
Visually, yeah. Visual learning is so much easier.
It's so much easier. It is for me, and the vast majority of students I work with. And even if you want to sort of redraw this triangle a little bit more to scale, right? Because, the width is a little bit smaller than the length. You know, you could do that just to help you kind of conceptualize it more. If you wanted to, you could redraw it.
It's up and down.
Right. I mean, it looks something a little more like that. But again, it's not a big deal. It's what we had still worked. But once you start thinking in sort of common sense visual terms on a geometry question, sometimes that's enough. I'd say most of the time that's enough to get you the right answer. That's the case here. Any questions about that?
No, sir. I think it's good.
Great job. Not the last geometry question we're going to see, but
lovely.
yeah, that's right. But I don't think it's too bad. I think we got another.
No.
Yeah, we do have another geometry one coming up.
I don't think in geometry terms because I've just been in algebra for so long.
Yeah, I get that.
I'll get it.
I get that. Go and read number 13 for us, please.
All right, let's see. In the figure below, C is the intersection of, what is that?
Line AD.
Something
line,
over AD.
Yeah, there's just line AD, right? Line AD would be this line right here. That's line AD.
Okay. Yeah. And line BE. If it can be determined, what is the measure of, how do I say
that's angle BAC.
Angle BAC.
Yeah,
okay.
Angle BAC. First of all, do you have any idea what that means, angle BAC? That's one of the angles here in this figure. Do you know what that means?
So I'm assuming that's the angle from B to A to C.
It's exactly right. It's the angle from B to A to C. So, I mean, like, start there. Here's B, and then we go to A, and then we go to C.
Yep,
right?
so you got it right there.
It's that angle right there. That's it. That's BAC. Yeah. Sort of it's going to be the middle, point, amongst a set of 3 points. That's going to be where the angle is at that middle point. Does that make sense?
I think so, yep.
Okay, yeah. So we're solving for that. Angle BAC. Okay. Let's start here. Okay, I want to make this really, really clear that geometry questions on the ACT are drawn to scale. They're drawn to scale. On the SAT, sometimes you see some figures that are not drawn to scale, but they always tell you if it's not drawn to scale. But on the ACT, every single question I've ever seen is drawn to scale.
Okay.
So we can kind of trust the way that it looks. Does that make some sense?
Mm-hmm.
Okay. All right.
Yes.
So just thinking in terms of visual estimation, there's probably an answer choice that we can get rid of that just doesn't look like BAC is going to be. It just wouldn't make sense visually if you know what a 90-degree angle looks like. By the way, do you know what a 90-degree angle looks like?
I mean, it's just I
can show. I mean, it's the corner of a square.
Yeah.
There's a square.
So
there's
like
a 90-degree angle right there. Yeah, exactly. It's like an L.
Yeah.
Right. The angle in an L. That's an
L.
90-degree angle.
Gotcha.
Right?
Yep.
So my first question here is does angle BAC look like it's bigger than 90 degrees or smaller than 90 degrees or equal to 90 degrees?
It's bigger, right?
It's a little bit bigger.
Or like wider, yeah.
Yeah, absolutely. So we can get rid of one answer choice. Yeah, 80 is out of the question.
Yep, because, I mean, if you add up it just doesn't make sense.
It doesn't make sense. It's too small, right?
Mm-hmm.
I would be very suspicious of answer choice E. I have seen that on a question or two on the ACT where they don't give you enough information, but most of the time they do. I'd be very suspicious of E. So if I'm guessing, I would guess between B, C, and D here.
Okay.
I would.
Because those are all, close together. You kind of just
tell and that's going to be tough,
probably
right?
An answer.
Exactly, right? They're all pretty reasonable. It's bigger than 90. If you were going to guess, which one would you guess? I'm just curious.
Probably C.
Yeah.
Just because, I would say D, actually.
B? Yeah, B or C. I'm not quite... I don't remember what the answer is here. Yeah, both B or C would be good. I wouldn't do something with 5... Well, that's possible. It could have a 5 at the end of it. I'm not sure. I really don't know. They're all pretty reasonable. It's tough to say.
They're all really close.
Yeah,
so.
but at the very least, once you get this far, you've got a 1 in 3 chance now, right, of getting the right
which
answer.
Is a lot better
which is better than 1 out of 5, right? Absolutely. You got a 33% chance as opposed to a 20% chance. So play those odds. Get rid of bad answer choices. Okay? All right, let's do the math on this. The first thing I want to point out is that we know what this angle is right here. We know what that angle is right there. Because it's across from this angle right here. If you got 2 lines and 2 angles that are across from each other from 2 lines, those are called vertical angles. And
it just gives you the answer.
Vertical angles are always equal to each other.
Yes. Okay.
Okay. Have you seen that before? Is that somewhat familiar in geometry?
Well, I really have done no geometry. Yeah, any geometry. So
yeah, no problem. But just look at those two angles.
It just makes sense.
Do they look like they're equal?
Yeah.
Heck yeah. I mean, and you could play around with some other lines. I mean, like, draw two straight lines. I mean, I'll do my best here on the whiteboard, but I mean, like, any two angles, you've got two straight lines, any two angles that are opposite each other are going to be equal.
They're going to, yep.
There's no way around it, right? Those two angles are equal, but also these two angles here are also equal, but they even look equal.
Yep.
Does that make sense?
Yes, it does.
Okay, good. All right, so we know that this angle right here
is 45.
Is 45, absolutely. Okay, and we're actually really close to finding the right answer now. Because we know every triangle adds up to, do you know how many degrees are there in a triangle?
I do not.
Every triangle has 180 degrees.
180 degrees, okay.
Yeah, you got to know that. I think that might be on the rules. Let me double check real quick. There we go. Okay. Second bullet point in geometry, right? Oh, wait, no, that's straight line. Okay, it's first bullet point. There we go.
First bullet, all angles in a triangle add up to 180 degrees.
Yeah, okay. All right, so you do have to know that, right?
Okay, I will. I will.
Good. So 180 degrees. So if the triangle has, that bottom left triangle has 180 degrees total, which all triangles do, then we just got to find the value for BAC where everything adds up to 180.
Okay. So whatever adds up to 180 from the 35 and 45?
Yep, for all three angles. Yeah.
Okay.
So what's the right answer?
It would be, but we don't know. Hold on.
So
can you explain that?
Yeah, we could approach it a couple ways, right? I mean, like, we could take 180 degrees and then subtract these two values and we'll find the answer. Right? We could do that.
Okay.
Or we could add up those two angles. By the way, what do those two angles add up as?
80.
80. So what value is going to take us to 180?
100.
100.
Okay.
Which is interesting.
Because triangle, yep, 180. Okay. So I was like, what's the third number there?
Yeah. Well, that's what we're trying to figure out, right?
180. Yep.
That's going to be 100 degrees.
Okay.
Which is interesting. I think that was your guess. I think you initially said C, and then you're like, maybe B, right? I think you settled on B, right? Which makes sense, right? Because it's not a ton bigger than 90. It's bigger than 90, but not a ton bigger than 90.
Yeah. Okay. So I mean, 100 made sense.
Even if you would have guessed visually, you would have gotten it right. Now, again, there's a little bit of chance involved there, right? Because, could you really tell the difference between a 100 degree and a 110 degree angle?
Yeah.
I can't. 115 does feel too big, though. I think it does.
Okay.
But once you know that a triangle has 180 degrees, you can figure it out. It's no problem. Does that make sense?
Okay. I think so. Yep.
It's not too bad.
Not too bad.
It's not. I mean, you got to know some stuff, right? You got to know vertical
when you break
angles
it down.
Equal. Yeah.
It's not too difficult.
It's doable. It's really doable. Any questions before we move on?
I don't think so.
Okay,
nope.
Great.
Pretty clueless in geometry, though. I think we're figuring that out.
Yeah, that's okay. But I mean, look, that just gives us the opportunity to kind of go over the basics and really have a good foundation. But you see, I mean, once you look at it the right way, then there's nothing you can't understand. You got it.
Okay. For sure.
Go and read question number 14 for us, please.
Is that supposed to be a name?
I think it is. Antoine.
Antoine. Okay. Antoine drew the circle graph below, describing his time spent at school in one day. His teacher said that the numbers of hours listed were correct, but that the central angle measures for the sectors were not correct. What should be the central angle measure for the core subject's sector?
Ooh. What are we solving for here? There's a lot going on there, yeah. What are we solving for here?
What should be the central angle measure for the core subject sector, whatever the heck that means.
Yeah. So, I mean, there's basically what we're solving for is the angle measure for the core subject's sector. This is the core subject sector right here, right? This top one.
Okay.
And right now, if this were drawn to scale, that central angle would be 180 degrees.
Yep.
Okay, straight lines in tech, that's also on the cheat sheet. Let me go to that real quick. That is the second bullet point, right? A straight line has 180 degrees of angle. Okay. Which shouldn't surprise you too much, right? Because, again, a 90-degree angle, is that L shape, right? So there's 90 degrees. So then another 90 degrees would be just, 90 degrees here, 90 degrees here. That's going to add up to 180.
180.
So that straight line has 180 degrees. Does that make sense?
Yep.
Okay, but we know here in this case they tell us, right? This is not drawn to scale, so I don't want to contradict my previous point. The point of this question is, and it's rare, but it's not drawn to scale. We need to either redraw it to scale, which is an option, or kind of figure it out mathematically. We've got some options here. Okay.
Okay.
I want to start with actually kind of redrawing this to scale. Okay. I think we're going to be able to do this. Okay, but let's study this chart here first, real quick. Let's understand what's happening here. Notice the core subject sector, that's the biggest one. That's 4 hours.
Mm-hmm.
Okay. Just below that to the left, electives is 3 hours. Lunch and passing time is 1 hour. Now, what's really funny is that
this 1 hour and the 3 hours.
This is 4 hours, but this is supposed to be 4 hours here as well.
Mm-hmm.
But look how much bigger the core subjects is than the others.
Yeah, it's definitely a little wonky.
It's a little wonky, yeah. And the core subjects is probably a little too big.
Mm-hmm.
Especially, right, because then we've got this other choir, which is another hour right here. So this bottom half of this graph here that's going to be 5 hours altogether.
5 hours, yep.
Right?
Can't be right.
So it can't be right? Because that's just got to be bigger than the 4 hours. Does that make some sense?
Mm-hmm.
So if we're sort of redrawing this to scale, and I'm just going to kind of redraw it here just to the right of the question.
Okay.
A little bit smaller. I'm going to try to draw a wobbly circle here. There we go. That's nice and wobbly. Okay, great. So if we're going to redraw that core subjects area, right, we said that's going to have to be a little bit smaller than it is in the current figure, right?
Mm-hmm.
It looks something like this, maybe. That angle.
Yeah, you really just need to add 1 hour triangle kind of into the 4 hours.
Kind of. Yeah.
A little bit, yeah.
Yeah, and I'll make this one like the 3, and then something, there's the 1 and the 1.
Yeah.
It's going to look something like that. Does that make some sense?
Yes, it does.
Okay. I really recommend starting there. If you can redraw it to scale. But again, just think in kind of like basic common sense sort of visual terms. But still, this is the angle we're looking for, is this one here. That's the 4 hours of the core subjects.
Okay.
Does that make sense?
Yes.
Okay. How many degrees does that look like to you, that angle I've marked in yellow? If you were going to guess. It's got to be less than 180, right?
Mm-hmm, but it's got to be more than 90.
More than 90, probably.
Say like 120 maybe, 130.
Yeah, it could be 120, 130.
Maybe a little bit more.
But you're right. We know it's less than 180, but more than 90.
So,
look at the answer choices.
Oh, yeah. I guess that would make sense.
What's the right answer?
160?
It's got to be 160.
Okay.
It's the only one that makes sense, right?
Mm-hmm.
It's not bigger than 180. It can't be.
Nope, because it's not a straight line.
It's just not less than 1... It's just not less than 90, but F and G are less than 90.
So it just makes sense right there in the middle.
Sense, yeah. And that's it. It's H.
Well, that's easy.
It is easy, right? If you can think about it in sort of common sense visual terms.
Mm-hmm.
Absolutely. Let's talk about the math here on this, though, because the math isn't too bad, okay? And I want to be able to do both. I want to give you as many sort of tools in your toolkit as I can give you.
Yeah, for sure.
So, the idea is you need to recognize that the core subjects is what fraction of the total number of hours? That's sort of the question. Okay, well, how many total hours do we have?
7, 8, 9, 8?
Yeah.
Can't do math.
Well, you tell me. Is it 8 or 9?
It's 9.
It's 9 hours. Yeah, there's 9 total hours. I'm going to make a note of that. 9 hours total.
9.
And we're talking about 4 hours out of the 9 hours.
Mm-hmm.
So that's a fraction right there.
Oh, yeah. For sure.
So we know the core subjects is 4/9 of the total number of hours.
Mm-hmm.
Does that make sense?
I think so, yep.
Okay.
Because it's 4 of the 9.
Yeah.
Yep.
So here's another question for you. Do you know how many degrees there are in a circle, Abby?
No.
Okay. I'll just tell you right now, there are 360 degrees in a circle.
Okay.
Which shouldn't surprise you too much. Let's assume that this figure is drawn to scale. Let's pretend that's drawn to scale. If this angle here is 180 degrees, right? Straight lines are 180 degrees.
Mm-hmm.
Then this angle down here would also be 180 degrees, that other straight line.
Mm-hmm.
Does that make sense?
Which is just...
And then so it's just 180 plus 180, and you get 360 degrees.
360.
I do recommend knowing that. That's pretty helpful. That circles have 360 degrees.
Just basic geometry.
Just basic geometry, right? They haven't studied yet, right? So don't worry about it. That's why we're going over it right now. Okay?
Okay.
All right. So triangles have 180 degrees, circles have 360 degrees. So if you want to find out what angle that should be, how many degrees that should be, that core subjects sector. That core subject sector is just going to be 4/9 of 360.
Okay.
So really the calculation is just 4/9 times 360 degrees, and that'll tell you how many degrees that is. Does that make some sense?
I think so, yeah.
Okay, that should work. Now,
Pretty sure.
We could do some like operations with fractions here. We could do that. I don't think there's any need to because you've got that freaking calculator all over the ACT math section. Mm-hmm. So here's how I'd calculate. I'd take 4 and divide it by 9. So why don't you go and do that with your calculator, with your iPhone, whatever.
Which is 0.4 to the infinity.
Yeah, I got 0.444444.
444, yeah.
Okay, all right. Mm-hmm. And then just leave that number up there in your calculator and then multiply that by 360.
Which is 160.
And that's our answer.
Cool.
So that's sort of the math way to do it. Does that second way make sense?
Yes, it does.
Okay. If you want to find the fraction of something, just multiply it by the total value by
how much there is,
by the fraction. That's it. If you want to find half of something, multiply it by half. If you want to find a third of something, multiply it by a third. If you want to find a quarter of something, multiply it by a fourth.
I wish all math was so common sense based.
Well, it can be.
It can be. I just taught wise. Yeah.
I've got a big issue. I mean, in case I haven't made it clear yet, maybe I think I've talked about in some other videos as well. Like I just got a bone to pick with how math is taught in general. It really should all make perfect sense, and nothing should be more logical. Sense. It really should. And the problem is most math classes get caught up in operations-based math. Do you know what I mean when I say operations-based math?
Yes.
It's like, okay, say this question, here's the 7 steps, do all these 7 steps, do the things. So math students, they're used to doing a bunch of stuff, but not understanding it.
I don't even think about the question. I just figure out how to solve it.
I know,
so
right?
It's just doesn't make any sense.
And that's just useless. That's really I should say almost useless. Look, if you're going to be an engineer or you're getting involved in
you need to know how to
programming, sometimes you just got to crank out some operations. That's true. But even then, there's a way to understand it and to make sense of it. So I'm on a mission.
Math is supposed to be used in everyday life, and so if you can't think about it in everyday life terms, it just it doesn't make sense.
I know.
It's learning two separate things.
I know. I agree. That's
crazy.
That's my mission here is just to make it make sense. So
make it make sense.
That's
a great mission.
Thank you. I appreciate it. All right, let's keep rolling. Yeah. Hopefully the next one makes sense as well. But I think so far we're good.
Well, with someone who struggles with math, it just if you can break it down in common sense, I mean, she's using another part of my brain that will make sense. Yeah. So it's just easier.
That's what I'm going for. All right, go ahead and read question number 15 for us, please.
This month, Cami sold 70 figurines in two sizes. The large figurines sold for $12 each, and the small figurines sold for $8 each. The amount of money he received from the sales of the large figurines was equal to the amount of money he received from the sales of the small figurines. How many large figurines did Cami sell this month?
Oh boy.
That's again a lot. So many words.
A lot of stuff going on there, right? And it's easy to just kind of read through that question and it go right over your head. And that is, I have that experience every time I read a question like this. I'm like, okay, I didn't really process that.
Yeah, I got to go back and break it down.
You might have to go back and reread it, and that's totally cool. We'll do that in just a moment. But first, let's really focus in. What are we solving for here with this question, Abby?
How many large figurines did Cami sell this month? The large figurines.
The large figurines. That's what we're looking for.
Okay.
Now, I don't know if this is obvious here. Maybe some students watching the recording, it's obvious too. They're testing you on something called systems of equations.
Okay.
Are you familiar with systems of equations?
Oh, I'm sure, yeah.
You've got 2 equations and 2 unknowns. Yeah, you've probably done stuff with, operations with it before and solved for them before. You can do that. You can set up 2 equations with these 2 unknowns, right? Because we've got an unknown value of large figurines and an unknown value of the small figurines. You can set up 2 equations and solve it. That totally works. We might talk about that here in just a minute. We may not. I'm not sure yet. But if we really focus in on the question, right, how many large figurines did Cami sell? We've got 5 possible answer choices. It's 20, 28, 35, 42, or 50.
Okay.
We can just test these answer choices.
Yeah, well, by setting up the equation.
Well, no, I don't think we even need to set up an equation.
Oh, okay.
Okay.
2, okay.
Because we know Cami sold 70 figurines. We know that.
And two sizes, so half, or not half, but we're trying to figure out how much.
Yeah, there's two sizes. So let's assume that answer choice A is correct. Let's say, okay, he sold 20 large figurines.
Mm-hmm.
Right, I'm going to make a little t-shirt here. We got large figurines, we got small figurines. Let's assume it's 20 large figurines. Well, then we know how many small figurines he sold.
It would be 50.
It would be 50 because it's got to add up to 70. Does that make sense?
Mm-hmm. Yes, it does.
Now we can test these values because the question says the amount of money he received from the sales of the large figurines was equal to the amount of money received from the sales of the small figurines.
Mm-hmm.
How much did the large figurines sell for?
So...
They tell us in the question.
20? Okay. 12. The large figurines sold for $12 each.
$12
and
each,
the small figurines sold for $8 each. Okay.
Yeah. So, look, if we multiply the number of large figurines, 20, by $12, we'll find out how much money he made from the large figurines.
Okay.
Right? And if we multiply the small number of small figurines, 50, by 8, we'll find out how much he made from the small figurines.
Mm-hmm.
And if answer choice A is correct, then those two will equal each other.
Oh, okay.
Does that make some sense?
Yes.
Okay.
So
let's do it. So what's 20 times 12? We'll start there.
240.
It's 240.
240.
Sounds right. $240. And then what's 50 times 8?
400.
400. Do those two equal each other?
Nope.
No way. So it's not
right.
It's not answer choice A. Does that make sense?
Mm-hmm.
Do you see how even though we don't know, we're at least we're not setting up these
a whole equation.
Right, yeah, you can still just see.
Kind of a layout.
Yeah, I can see if answer choice A works. I can see if B works. I can see if C works. A doesn't work. So let's test answer choice B. So I'm going to change the number of large figurines to 28. How many small figurines were sold if 28 large ones were sold?
Math. Hold on. 30.
Yeah.
No. 22, 30, 20, 32?
32?
No. Yep.
Should just be 70 minus 28. You can use that calculator.
70? Wait. Oh my gosh. Sorry.
Yeah.
I was thinking of 50. Oh my gosh. Okay. 70 minus 28. 42? Yes?
Yeah, that sounds right.
Oh my gosh. Okay.
We're good. Once again, I mean, use that calculator. Use that calculator. You don't have to do it mentally.
I don't know why 50 popped in my brain.
Well, because the last value for the small figurines was 50. So that's it. We're just keeping it straight that there's 70 total.
Yeah, and it'd be 22, so I was wrong either way.
Yeah, that is correct. Yes, that is correct.
Man. Okay.
That's right. We're still good.
Yeah.
All right. So how much did he make from the large figurines? Let's calculate it.
$12 each?
28. Yeah, 28 times 12.
But we're doing the math. Yep. Mm-hmm.
Just punch it in the calculator.
Times 28. 336.
Yeah, 336. How much from the small figurines?
12. Okay, 42 times 8. 336. Oh, there we go.
There we go.
Mm-hmm.
That should be it. I mean, we could test the others, but I don't think we need to because if B works, the others aren't going to.
Then, yeah. Save time.
Yeah. That's not too bad, is it?
Nope.
Okay.
So B is the answer.
Yeah, that's it. Do you want to talk about the algebra on this? Would it be helpful?
No.
We
don't have to.
Like,
but we can. We can.
No. I don't know. I don't think I want to. I don't think I want to.
Okay.
There's so many questions like this on the ACT where they want you to set something up, and it's like, just test the answers. You're almost guaranteed to get it if you can do basic arithmetic.
Mm-hmm.
And you've got a calculator. So as long as you kind of keep everything straight, there's nothing to set up. There's nothing to set up.
So much simpler.
So much simpler. Any questions before we move on?
No, sir.
Okay, good. We might see some.
Do more algebra.
Yeah, we might. I mean, look, I'm all about avoiding as much as possible.
Okay.
Because
cool.
I still get messed up on operate. Like if you've got 10 steps to do, the chances of
getting it right is just easier to test answers.
Yeah, I agree. All right, question number 16. Go ahead and read that for us, please.
Okay. A car accelerated from 88 feet per second to 220 feet per second in exactly 3 seconds. Assuming the acceleration was constant, what was the car's acceleration in feet per second, from 88 feet per second to 220 feet per second?
Yeah, do you have any idea what they're asking us for here in this question, Abby? And you can say no if you have to.
So, I have to reread it.
Yeah, go ahead. Go ahead.
Nope, I'm going to say no.
Okay. What are we solving for?
We're solving for the car's acceleration in feet per second from 88. Oh, so are you just subtracting 220 from 88?
Well, I don't know.
No,
see, this reminds me a little bit of the question we did in the previous recording, right? Where I think it was the one that was like, if half an inch represents 18 miles or something like that, right? How much does...
Oh, yeah.
Right? You remember that one on the map?
I think, maybe.
Okay, we did a question that was asking how much, like, how much 2.5 inches represents on a map.
Okay, yep.
And the approach we did on that question was like, let's just draw a picture. Let's think about this in concrete terms. Let's just think about the situation clearly first. I want to do the same thing here. I want to draw a picture of this, okay? Let me start it. I'll start it. So we've got a car. It's starting at 88 feet per second, and it's going to end up at 220 feet per second. So I'm just going to make some notes here. So 88 feet per second already. FPS. And then we end up at 220 feet per second. Okay. Does that make sense? So starting acceleration or end acceleration. Okay.
Gotcha.
And that change takes place in 3 seconds. Exactly 3 seconds. So I'm going to split that up into 3 parts, each representing 1 second. There's 1 second, there's 2 seconds, and there's 3 seconds. So I'm going to make notes of that too. 1 second. Right. Notice we're not starting with 1 second here. That's at 0 seconds.
Yes.
Right. I mean, in fact, I'm making note of that. That's 0 seconds. 2 seconds. Apologize for the terrible handwriting.
Nope, it's all good.
We're in good company, I promise you. Okay. There we go. Okay, great. So we've got to figure out how much it's accelerating per second. Basically, how much is accelerating per each second? That's the question. So one of these answer choices is going to take us up to 220 feet per second. And 4 of them just won't take us up there. Does that make some sense?
I think so.
Okay.
I'm pretty sure.
We can test these answer choices. We can test these answer choices. Look at answer choice F. If it's accelerating 1/44th of a foot per second, is that going to get us up to 220 feet per second?
I don't think so.
I don't think so. Right? Like, I'm not sure that's going to get us to 89 feet per second. It won't. Does that make sense?
I think so.
Yeah. It's just too small.
Would it just be... Yeah, okay.
It's too small. Let's try 29 1/3 feet per second. Okay.
Okay.
How could we test that?
Can you multiply it by 3?
Yeah, multiply by 3 and then add it to 88.
Yes, okay.
And see if that gets us up to 220. Yeah, or you can just add it 3 times to 88, but it's the same thing.
Yes, but it's not enough. So
I don't think that's enough. Yeah, because that's going to be like, or is
175,
hold on.
something like that.
Let me do it real quick. Hold on.
Okay.
29. I'm just going to do 0.333333. So I'll do a fraction.
Yeah.
Times 3. Okay, yeah, that gives us like 80.
180 something.
Yeah, it gives us 88 feet per second, and then add that to... That's not going to be enough. You're right. So it's not... Okay. Make sense?
Yes.
Let's try 44.
Okay. So 44 times 3 equals 132 plus 88, which is 220. So that's a fair answer.
That looks pretty good, right? But if that works, right, how is it going to be J or K? It can't. It can't be J or K. Does that make some sense?
Yeah.
Yeah.
Because those are way too big.
Those are just way too big. So it's got to be H, and it is.
In my brain, I just think... Oh, sorry.
No, what were you saying?
I was just saying, in my head, when I think of this, I just, like, multiply 3 times the number, and then you kind of just, like, like in my head, I can kind of be like, oh, it's too much, too little.
Yeah. I see what you exactly, right? Yeah, you knew that was
3.
G, right? That wasn't going to get you, because you don't even get 100 when you multiply answer choice G by 3.
I didn't even add the 1/3. I just did the 29. And
yeah, right? I love it, right? Because just estimating, just feeling that out like you did is enough to get rid of G. Absolutely. Certainly enough to get rid of F. If you wanted to, if you wanted to be extra careful, you could like literally just add 44 3 times. So 88 plus 44 is 132. So that's going to be 132 feet per second there. I'll add 44 again. I get 176. I add 44 again. I should get 120.
Yeah.
Or 220. Yeah, and I do there. Okay,
3 parts.
So that's it. Absolutely, right? So, which is why you can just multiply the answers by 3 and add them to 88.
Okay.
Now I think we see the operation. If you wanted to sort of like mess with these values that they give you in the question, and you want to find out the acceleration per second, you subtract 88 from 220. So it's 220 minus 88. You get 132.
Let's see. Yep.
And then divide by 3 because it's happening over 3 seconds.
Oh.
Right, and that gives you 44. So that's how you how you solve it to find the answer.
Okay.
But I think doing that's tough, right? It's like, because you just hope you got the operation right. But when you're testing the answer choices, it'd be like, okay, F doesn't work. Okay, G doesn't work. Oh, H works. Okay, and you have to worry about setting it up right. Any questions about that?
I don't think so.
Okay. It's not too bad once you kind of lay it out and see
it.
But you really have to conceptualize the question the right way first, which is why I just love drawing pictures. It just helps you think about it correctly. And then once you can think about it the right way, then what to do is much more obvious. All right. Level of difficulty is bumping up a little bit. As you work your way through an ACT practice test, I would argue questions 1 through 30 are pretty straightforward. There's some tough ones peppered in there, but mostly pretty straightforward. Once you get past the 30s, and we'll see some of those, a little bit later, the level of difficulty definitely bumps up,
Okay. How many questions?
60 questions.
60, okay.
And the tricky part is they give you 60 minutes
to
answer those 60. Yeah, so you got a minute per question.
Okay.
You just can't spend like 5 minutes on a question. It's going to kill you.
Yeah.
Okay. Kill you. I tell students all the time, it's not the questions you get wrong that kill you. It's the questions you spend 5 minutes on.
Okay.
You just got.
So do students normally finish the whole thing?
I mean, with prep, yes.
With prep,
yes.
Okay.
Without prep, it's very common not to finish one or multiple sections. Yeah.
This is like really bad not to finish.
It's not great because there's some easy questions at the end that you've got to get to.
Okay.
The trick is just focus on the ones you should be getting if you take the time on them. And then if you see a really high level difficulty question, just skip it. Like if you read the question, you're like, I have no idea what's asking. I have no idea what's going on here. Pick something and move on. You can always come back to it if you need to. Okay. But you can't spend 4 or 5 minutes just trying to figure out what's going on with the question. You just don't have the time to do that.
Okay.
That's the trick. It's just practicing not getting stuck. And you got to have like a mental clock. If you're still, a minute and a half or 2 minutes have passed and you're still trying to figure out what's going on in a question, no, you just got to cut your losses. You just got to,
okay. So should I be practicing, like, do I ever need to practice, like, trying to get these in under a minute?
We'll get to all that later. That happens later in prep. But I'll just tell you, anybody watching the recording right now that's wondering how to prep for this test. I mean, I always start with untimed work like we're doing right now. Like, I have no problem spending 5, 10, 15 minutes on a question. I've done, I'll do that with the student, like just hashing it out, understanding the concepts, approaching it with the right strategies. Let's take as much time as we need to at this stage of the prep, right? And you're just getting started. So let's take our time and understand it. Because the nice thing is once you understand the concepts, then the speed naturally improves.
Just comes in,
Yeah, right, because you're like, oh, I've seen this question before. Oh, come on, every circle's got 360 degrees, easy. Oh, every triangle's got 100 degrees, okay. No problem. Vertical angles, okay. Like the speed comes right when you understand the concepts.
Yes.
But you have to understand it first. So you really, anybody that's doing any prep on your own, I mean, keep watching my videos, obviously. Well, make sure to like and subscribe as well. But anyway, but start untimed. Start untimed. You have to.
Untimed. Okay.
Because you just have
to
understand and think about the questions the right way first.
Okay.
Later on, when you're getting the score increase you want to see untimed, then you add the timed element. But those are two different processes. Start untimed, always.
Okay.
Okay, that's
Sounds
what we're doing now. Go to read number 17
All
for
right.
us. More geometry. All right.
Let's see. In a plane, the distinct lines A to B. Did I just say A to B?
Yeah, I'd say
AB.
line segment AB.
Line segment A to B.
Oh no, I'm sorry. Those aren't segments. Are those segments? I don't know. Anyway, it's line AB and CD. Go ahead.
Okay, line AB and line CD intersect at A, where A is between C and D. The measure of angle BAC is 47 degrees. What is the measure of angle BAD?
What in the heck are we solving for here?
The measure of angle BAD.
BAD. Whatever that is, I have no idea. Okay. Look, I've done this question before. I can't tell you how many times with students. I have no idea what's happening here right now. I really don't. Like, genuinely no clue. I can't even imagine right now. I need to see it. I need to see it. I need to see these two lines. So let's draw these lines.
Is this like the other question with like the crazy triangle that was like
maybe a little bit? It feels like it, doesn't it? It feels like, but I just need to see it because I don't even know what's happening. We've got two lines, AB and CD. They intersect at A. A is between C and D. Can we start trying to draw this? Just draw me a line. Let's start with one line. I don't care.
Okay.
Draw me a line.
Like that. Was it good?
Yeah, why not? Great.
I can go up and down.
No, that's good. Okay, let's make that A B. Okay, I'm gonna make that so there's a point A. Here's a point B. That's AB. Okay, and then AB and then CD intersect at A, where A is between C and D. Okay. I'm starting to get a handle on this now. So CD goes through A. It intersects at A.
Like this?
Yeah, something like that.
Okay.
Yeah. So that would be... Yeah. We might have to redraw this, but I think this will work.
Okay.
So here's C, here's D, right? Because A is between C and D. They tell us that. Does that make sense?
A, okay, yep. So in the middle. Yep.
And then the measure of BAC is 47 degrees. So which angle is BAC? I think this is going to work out beautifully.
Okay, right there. Did you see my dots?
Yeah, BAC, right? So we're looking for this angle right there. BAC is 47 degrees. They tell us in the question. But look at that. Hold on a second. This is nearly perfect. Because that angle looks like darn close to 47 degrees. Do you know what 47 degrees looks like?
I do not.
Well, you know what 90 degrees looks like.
Okay, yeah, that's
right?
true.
That's 90 degrees. And kind of
70 degrees.
So 47 degrees is close to half of 90 degrees. So like that angle there would be like 45 or 47 degrees. I couldn't tell you the difference there.
Okay, so that worked out well.
So that worked out really nice. We might have just got lucky there. Right? Once you start drawing it, there you can be like, okay, that's not the right angle, and you could adjust it if you needed to. But that worked out beautifully. Is that clear?
I think so. Yeah.
Yeah. Again, if BAC was like 120 degrees, well, then we just draw a different line, right, and fix it. But here it just worked out really, really nicely. Okay, and then we're solving for the measure of angle BAD. Where's angle BAD?
That was awful.
That one, right? No, you're good. You're good. That's BAD. Absolutely, right there. Right there. That's BAD. Okay, great. I think we're on the right track.
Okay.
I think we're on the right track. I'm not certain what the right answer is, but I think I can get rid of at least 3 answer choices that I know are not going to be BAD.
Okay.
What answer choice can we get rid of right off the bat?
Probably what? D and E? Is that
Why D and E?
Way too much?
Why D and E?
Well, in my head, I'm just saying 43, 47, 94 are the closest together. So.
Well, are you looking at this? Are you looking at this angle? Are you looking at BAD?
Oh, well, not right now.
Yeah, look at BAD.
Yeah, it's way not. It just doesn't make sense.
Well, hold on. Is BAD bigger than 90, less than 90, or equal to 90?
So it's way more than 90.
It's way more than 90.
Oh, okay. So I'm totally wrong.
Yeah.
So
you were.
You gotta get out A and B.
A and B for sure.
Yeah, and it's not 90 because
it's just way bigger than 90.
That doesn't make sense either. Oh,
You know,
okay.
C is bigger than 90, but I think BAD is just much bigger than 90.
I was just thinking backwards. Okay.
Yeah,
It's all good.
Are we good now, though, right? Does that make sense? Why BAD
yeah, definitely.
is either D or E. If this is as far as you get, you got a 50-50 chance.
Yeah, okay.
Which I'm cool with. It's better than 1 in 5 chance, better than 20% chance.
Mm-hmm.
I'll take 50%. But we don't need to stop there, because I think we can figure out which one is right.
Mm-hmm.
Let's go back to that we were talking about earlier, right? Straight lines have 180 degrees.
Yep.
So the question is, what value for BAD is going to give us 180 degrees for that straight line?
Oh gosh, this is so much thinking. Okay.
You got this. You got this.
Okay, so straight line is one. So I have no idea what we're doing.
Well, yeah, no problem. I mean, is it clear that line CD is going to be 180 degrees? Is that clear?
Yes, because this is a straight line. Yep.
Yeah. So there's some value for angle BAD right here, some value. BAD. When we add that to 47, is it going to give us 180 degrees?
If we add that to...
Right? Because when we add BAD and 47, we need to get 180 degrees. It's a straight line.
Okay. So... Gosh, I'm very lost.
Yeah, no problem. Well, does it make sense when I add up these two angles right here, I need to get 180 degrees?
Yes.
Okay,
because
great.
Okay.
Well, let's just add 133 to 47.
So 180, is it 180 minus 47?
You could do 180 minus 47, or you could add up D and E to 47 and see if it equals 180. I don't care which.
D and E, okay.
Yeah, but let's do 180 minit's 47.
133.
Well, there you
okay.
Go.
I was so overthinking this. Okay.
Yeah, it's pretty straightforward.
Right? Okay.
It's got to be D.
So yep, D.
Okay. Any questions about that?
Cool, okay. I don't think so.
It's not, like, insanely difficult.
Mm-mm.
It's not. But if you don't draw it, I mean, it's not happening for me.
Yeah.
I just got to see it. But once you can see it, once you think about it the right way, then it's not bad. Do you have to know straight lines are 180 degrees? You do have to know that here.
Yes, okay.
And again, whether you want to test the answer choices to see which adds up to 180, or if you want to subtract, 180 minus 47, either way, doesn't matter. You'll get it.
Okay.
Any questions?
I don't think so.
Okay, good.
So actually,
yeah.
In that problem, can you not just immediately think 180 minus 47 because it gives you the number? Can you not do that?
I don't know. Well, I don't know. I'm gonna try to put that.
Kind of just depends on the question.
It does. Yeah, it does. I mean, let me put the question back up real quick. What was it? BAD.
If you really think about it, could you think, I'm trying to find what part of the angle isn't 47? So then you're just kind of 180 minus 47. I don't know.
Yeah, I'm sorry, I'm having some trouble with my whiteboard.
No, you're good.
But I'm trying to put the question back up.
It's just what I was
it wouldn't be obvious to me.
Okay.
I mean, to go right from this question to be that's going to be 100.
No, I don't think I could have figured it.
Yeah, to be
figured out.
I know there's going to be a straight line that's 180 degrees, and I just wouldn't. What if BAD was a vertical angle across from BAC?
Okay.
You know what I'm saying? Depending on the figure, it's possible. And of course, when you actually draw it, you realize it's not the case. But
yeah, okay, so you gotta at least kind of draw it.
You have to.
You get some idea.
Yes,
for sure. Okay,
yes.
Okay, that makes sense.
I think you have to. Good question. Great question. Yeah, otherwise it's just kind of number slapping. We've talked about that before.
Yeah,
you're just doing stuff.
Yeah, you want it to make sense.
Yeah. All right, go to read question number 18 for me, please.
All right. In which of the following are half, 5/6, and 5/8 arranged in ascending order? Ascending order.
Ascending order. Yeah. I mean, let's talk about that.
Basically, yeah.
That term first. What does ascending mean here?
Definition. Ascending would be going up?
Going up.
Mark?
Yeah, going up.
Okay.
Going up. So you're starting small and getting bigger.
Mm-hmm.
That's ascending order. Descending order would be you start with the biggest values and then they get smaller. That'd be descending order. So you got to know what that definition means, but that's not too bad, is it? Okay. So we're going from smallest to biggest.
Just
smallest to biggest. Okay.
Smallest to biggest. Oh, so is it just? Oh, so it's okay. I see what we're doing.
Now maybe I'm guessing, just looking at these fractions here, maybe it's not obvious. Maybe it is. Which is the smallest and which one's the biggest?
Mm-hmm.
Do you have any idea? Maybe you do.
It's not half for sure. So it's between 5/6 and 5/8. Is that right?
Well, at least the small. Let's start with the smallest. Which one do you think the smallest is?
5/8.
You think 5/8 is the smallest?
Yeah, I would say that.
We're gonna test it.
Maybe
here in just
not,
a moment.
but
yeah. Let's do this. Let's step back for a minute. Let's step back. I mean, if you're really comfortable with fractions, it may be. I think it's pretty straightforward. You can be like, oh, okay, I think that one's the smallest one, and once you know the smallest one, you can actually, I think, find the right answer. I'm fairly certain. I'm gonna test it here in just a moment. But if you're dealing with fractions on the ACT, you've got that calculator. You never really have to deal with fractions on the ACT. You can always turn them into decimals. If you want to find out how much 1/2 is, literally take 1, divide it by 2, and you get a decimal. Do it on your calculator real quick. What's 1 divided by 2?
Let's see. Okay. 1 divided by 2 is 0.5.
0.5. Does that make sense?
Yes. So you can, great. I mean, you really can just check these by decimals, right?
Yeah. Yeah. Let's find out what 5 divided by 6 is.
It is 0.8 and then 3. Yeah,
0.83 repeating. Right. Okay. What's 5/8? It's 5 divided by 8.
Is 0.625.
0.625. Which one's the smallest?
Is it half?
Yeah. 1/2 is the smallest. I mean, 0.5 is the smallest of the
values,
because...
Right?
Is that obvious?
Oh, Abigail.
No?
Yes.
Is that obvious?
Yes.
Oh, that's so funny. Right, you go by Abby, right? But if you're...
Yeah, sorry.
No, it's great. It's funny, right? That you revert back. I'm guessing you've heard that before. Maybe that's...
Yes.
Yeah. But, yeah.
Half, of course.
It's 0.5, right? Does that make sense now?
It's fine. Yeah, it should have been closest between, like... No, never mind. I don't know. I don't even know what I'm thinking.
The nice thing is, once you know that half is the smallest, you can find the right answer.
Okay, yep. So, it's just...
Because...
Yeah, because there's only one. It's F.
It's got to be F. Yeah.
Yep, okay.
It's got to be F.
Okay. That's what I thought. Like, right when I looked at this, I was like, oh, half is the smallest. It's F.
Yeah.
Because it's the only one. But then
you started second-guessing yourself.
Yep.
Yeah. But it makes sense. You don't need to guess it. All right, just turn it into a decimal. Anytime you see fractions, just turn it into...
Just turn it into a decimal.
Turn it into a decimal. Turn it into a decimal. You're good. Okay. But then again, if you arrange these, right, obviously, 0.5 is the smallest, and then the next smallest would be this 5/8, right? So that's got to go right there. But again, that's answer choice. That's answer choice F. So,
okay.
Any questions?
I don't think so.
Okay. Yes, don't worry about operating with fractions on the ACT. You can always turn it to a decimal. So
okay,
that's the case here. If you want it, there's another way to do it. Do I even want to do it? I mean, you could come up with a common denominator. Do you know what I'm talking about? You know what I'm talking about? You could do that. I don't know. I don't want to go over it now. I really don't want to go over it now. But that's a way to do it too. And then you see which one. Yeah, because 1/2 would be the same as. What's your common denominator? That's a little bit ugly here. It's going to have to be. Oh, what is it? It's gonna be 24.
Yeah, I
think it's gonna be 24.
Something like that.
So you get, but I don't want to do that. Yeah, just turn it to a decimal.
Yeah,
there you go.
Simplest way to do it.
Keep it simple. Let's do a couple more and we'll wrap it up. Oh, scientific notation.
Lovely.
Yeah, all right. Have you done scientific notation before?
I have.
Yeah, okay.
Actually.
Great. Okay.
Yeah.
We'll go ahead and read number 19 for us, please.
Okay, in scientific notation, 670 million plus 700 million equals what?
Yeah. We got to figure that out in scientific notation. Okay.
Okay.
You know where I would start here with this one? I would literally just add those on my calculator.
Okay, that's what I was going to do.
Are you cool with that? Yeah, let's do that real quick.
Yeah.
Come on.
Okay.
So I'm going to do 7. There's a lot of zeros here. So 6, 7, 8,
1. What am I doing? Oh, my goodness. Okay, let's see.
Plus.
So I've got 1.37.
Yeah, and then you got E9.
E9.
Do you know what that means?
I don't, actually. I feel like I should.
E means 10 to the power of.
10 to the power. Okay. Oh, okay.
Yeah.
Okay. On a calculator.
Yeah,
okay.
I think we know the answer right now, right? Just punching that into the calculator, right? What's the answer?
D.
It's got to be D. Yeah. I'm going to double check here in just a minute. But like, if we didn't, or if your calculator gave you an actual number, with the commas and everything like that, I think you'd get good heavens. What is that? Billion, right? 1 billion, 370 million. And then, that you get that.
Oh,
number.
So many zeros.
Yeah. Depending on your calculator, you might get that, right? Does that make sense? Well, it should add up to that value on the calculator.
Yeah.
The nice thing is, at least on the calculator we're using, it just jumps right into scientific notation. This is a breeze. You can just punch it in your calculator.
Yeah,
right?
it just gives you your answer right there.
Gives it to you. Yeah. If you know what that E means, right? Which now we do.
Yeah.
So, but I also want to practice taking this value right here and turning that into scientific notation. I want to practice that, right? Okay, so let's assume that's what you get in your calculator. How do we turn that to scientific notation? Well, there's an implied decimal right here, at the end of this term.
Always start with the decimal.
You could describe it as, 0.0 sort of at the end, but we'll just leave the decimal there. And then with scientific notation, you want to bring that as far as we can to the first term, but right after the first term. So I'm going to move that decimal, and we're going to count the spaces when we move over. So I'm moving over one space,
1, 2,
3, 4, 5, 6, right? See what I'm doing here?
Yep.
7, 8, 9 spaces. I'm going to move it right here, but I've moved 9 spaces. So I can describe that as 1.37.
Because it has to be between 1 and 10.
10 to the power of 9.
Front number. All right.
And that's it.
Yeah, I'm pretty, actually, what is the word?
Familiar, comfortable.
Familiar, with I don't know why that took me so long.
Yeah.
Scientific notation.
Okay, good. Yeah, if you're taking a chemistry class or a physics class.
Yeah, unfortunately.
Sure. Yeah, I got you. We know it's not A because something to a negative power is going to be very small. I mean, 10 to the power of -9 is going to be extremely small.
Something.
Yeah, this is not going to be extremely small. That's actually going to be quite large. Yeah,
huge.
Simply. And E is just too big. Even if you didn't do the let's say you forgot your calculator, for this test, God help you. But if you did, right? I mean, you didn't want to, calculate it, or you couldn't calculate it for some reason. A is too small, E is too big. It's just not that many digits for E. B through D are reasonable if you're just kind of feeling it out. But again, we can confirm it's answer choice D.
So are these questions, are some of these the exact things that we're doing on the? I mean, I'm assuming they are because we're working on them.
These are from an official ACT practice test.
Okay.
So I think these are representative of what you're going to see. At least these concepts. Okay. You're not going to see this exact question.
No. But the concepts for sure.
But the concepts, absolutely.
Cool.
Absolutely. Yep.
So are we going to break this down into? Oh, never mind. I don't need to.
Okay. What was your question? Go and lay it on me. What was your question?
I was just gonna say, if there's 60 questions.
Yeah, we're doing 10 at a time right now.
Okay.
Yeah.
Cool.
Okay. Go to read question 20. We're gonna end with some geometry here.
Okay. For trapezoid ABCD shown below, oh goodness, line AB, what is that?
It is parallel to line
to line DC. The measures of the interior angles are distinct, and the measure of angle D is X degrees. Yeah?
Yeah.
What is the degree measure of angle A in terms of X? Oh, my goodness.
So much going on here.
I don't even know if I can laugh at that.
Well, that's you can cry a little bit if you need to. You can cry quietly. Yeah.
Goodness.
What are we solving for here?
The degree measure of angle A in terms of X.
Yeah, the degree measure of angle A in terms of X. We're solving for A.
Okay.
In terms of X. Yeah.
Oh, yeah.
Okay. Well, this is drawn to scale, right? All the questions in the ACT, unless they mention, like that previous one.
Thank goodness,
but in general, it's drawn to scale. Here's what we can do. I mean, this looks so complicated. I'm not exactly sure how to do, the fancy algebra on this. I'm really not sure, but I'm not worried about it, because we can come up with a value for X. Let's come up with a reasonable estimate for X. Let's start there. And then we're dealing with real values and not just doing, abstract algebra.
Okay.
What's X look like it is?
Not a 90 degree
Not 90.
angle. It's smaller.
It's smaller than 90, but not a ton smaller. So what's a good estimate?
Maybe 84, 85, 80.
Yeah.
It's got to be over 80, I'd say, for sure.
Let's just say 80. Let's keep it simple.
80, okay.
Let's say 80.
Okay.
Let's say 80.
Okay.
So I'm gonna make it over that. Let's say 80 degrees. It's less than 90, but not a ton less. So x equals 80 degrees. Wonderful. Any questions about that so far?
No.
Okay. I think we can test these answer choices.
Okay.
I think we can test these answer choices. Because what does A look like? First of all, what does A look like? Give me an estimate for A.
Probably 100?
Like 100
maybe?
or 110, something like that? Yeah. It's bigger than 90, but not a ton bigger.
Yeah. Not a ton bigger. Okay.
Right? Something like 100.
Okay.
110 maybe. Plug in 80 for X into the answer choices.
80 for... Oh.
Yeah. Look at answer choice F.
Yeah. So, I mean,
what does that
is it
give
just 180 minus 80?
Which
is that right?
What? Yeah, which is what?
100.
Does A look like it could be 100?
Yes.
Could be. Keep it.
For sure.
Keep it.
Okay. Because it makes sense.
Yeah, because it makes sense. What about G?
Okay. G, okay. So, 80 times 0.5. Sorry, I'm yawning.
Yeah, you're good. Yawn is just a deep breath. No problem.
So it's 140.
So that would be 140, right? Yeah, 0.5 times 80 is 40, so 180 minus 40. Does A look like it could be 140?
Probably not.
Probably not. 140 is just too big.
Yeah.
Like 140 is going to be...
Get rid of G.
Yeah, I think so, right? Because 140 is going to be like a 90-degree angle plus half of another 90-degree angle. That would actually be one...
Yeah, because it's...
That would be like 135. But still, I mean, like that's going to be 140. Something like that.
Okay.
You know,
yeah.
Angle right there. That's just too big. So probably not G. What about H?
Okay. H is... Okay, so we're adding this
We're
time.
adding to 180. I don't think we need to... Right? Is it going to be bigger than 1...
Yeah.
Is A bigger than 180?
Yeah, that doesn't make sense.
No, it doesn't make any sense. What about J?
J. Okay. Still too big.
Still even bigger than H.
Yep.
What about K?
K is just... I don't think that can be right.
No. It's not 80, right? We know A
that
is bigger than 90.
It's not 80. Yeah.
There we go.
Okay.
F is the only really reasonable answer choice.
All right, easy enough.
That's it, right? Once you start thinking in concrete terms with actual values, you can figure it all out. You can figure it all out. Even without having taken a geometry course.
Yeah. I mean,
you have to know what a 90-degree angle looks like.
I know nothing about geometry, and this makes sense.
And you can do it. Yeah, you have to know what 90 degrees looks like. You have to know what 180 degrees looks like. You got to be able to estimate angles
for sure.
and lengths.
But those are just pretty. I mean, that's
you already knew that. Yeah, that's you've covered that in middle school.
Yeah, I mean, that's just like child. Like child can figure that out.
I agree. I agree completely. Awesome.
Well, that's simple if you can think like a kid.
yeah. I do tell students from time to time, like, you gotta think dumb. You gotta think
geometry.
Keep
for
it
sure.
Simple. Thinking in concrete terms with real values.
I kind of feel better about taking geometry. Just kind of being introduced to like the more important terms. I know what I'm supposed to be like.
Yeah. I think it's gonna make it easy for you when you do study. Are you going to that next year? Are you doing geometry next year?
Yes.
Okay, good.
As soon as possible.
Good. Well, I hope this is helpful. I think it will be.
Yeah, for sure.
Good. All right. Let's wrap it up there, Abby. Thank you so much for your participation today. And
of course. Thank you for teaching me.
It's my pleasure. I love doing it. So, all right. So if you're watching this recording, be on the lookout for the third part that's coming out soon. We'll continue working through this practice test and shooting through these questions and applying these strategies. Make sure to like this video, subscribe to my channel, all that stuff, and be on the lookout for thank you. Yeah, thank you. And be on the lookout for more videos coming out soon. All right. Thank you, Abby.
You're welcome.
I'll see you around soon.